This video we're going to be multiplying polynomials. So to multiply polynomials, before we get into that, we first need to know how to multiply monomials, or just straight up terms. So, and we kind of already did this, but like let's say an x times x to the third. Well, remember when you're multiplying, you have to add the powers. So think of that as like an x to the 1. So x to the 1 times x to the third. That's going to give me an x to the fourth. Okay. So we kind of already talked about that. We just have to add those exponents. But what happens when I just have a straight number with a variable to a power? Well, all you really need to do is just write them together. 2 times x to the fourth. I can't really do anything with that 2 and the 4, so we'll just leave them separate like that. Now throw in a little harder one. So we have 3x to the fifth times an x squared. The numbers in front, see if there's any. Well, there's no other number other than 3, so we'll just put the 3 out there. And then x to the fifth times x squared, that's going to give me an x to the seventh. Make sure to add those powers. And the last one, the 2 and the 3 can be multiplied together, so that'll give me a 6. The a to the third and the a to the fifth can be combined into a to the eighth. So knowing how to do this is very vital in this video. So we're first going to talk about distributing. So we have a monomial times a binomial. So we have one term multiplied by something with two terms. And whenever you encounter this, and I think we've already did distributing before, but remember you want to take what's out front and multiply it to the first term and to the second term. So 3 times 7m, that's going to give me a 21m. And then 3 times 2 will give me 6. So just like that. Now the 5n to the third, distribute that to both pieces. So 5n to the third times a 3n, 5 and 3 will give me 15. N to the third and n will give me an n to the fourth. 5n to the third and 5, well that's just going to give me a 25. And then don't forget that n to the third. Alright, now distributing this through. So 5x to the fourth times a 2x, so it's going to give me a 10. X to the fifth. 5x to the fourth minus 4. Multiplying those together, it's going to give me a negative 20. X to the fourth. Alright, now I want to show you guys actually a different way to think about this. And you can do this with your distributing problems. So take the term out front, write it down, and make a little box to the right of it. So just like this. So a little box, kind of a longer box, and then split it down the middle. And you can put the terms from the binomial in each part on the top box. So this is kind of a good visual aid that you can use. So it's kind of like a multiplication table. So 3 and 7 will give me 21, and then the m. And then 2 and 3 will give me a 6. So 21m plus 6, that was my answer. You can do the same thing for the next one. So 5n to the third times 3n and 5. So again, that was 15n to the fourth, and then 5n to the third. So this is a really good way of organizing your work. So again, that was my answer there. Just put a plus sign in the middle of it. And finally, 5 n to the x to the fourth. And make your little box. We got 2x minus 4. Make sure to put that negative with the 4. So that gave me that 10 x to the fifth. And then negative 20 x to the fourth. So just another way of thinking about the problems. So I had a little mess up when I was explaining the box method on the second one. So of course you have that 5n to the third. And then you have the 3n and the 5. And I made the mistake of saying that, well, this one times this is 5n cubed, when it should be 25 and n to the third. Okay, so it's okay. I made a little mess up, but that's what it's supposed to be. So anyway, going on. Here we're going to get to foiling. Now, what happens when we multiply a binomial times a binomial. Okay, so you notice how each binomial is in a set of parentheses. So for the first one, we have 8x plus 1 times 2x minus 3. And what we're going to kind of do is, it's kind of related to distributing, is we're going to multiply basically these two terms, which each individual term in the other set of the parentheses, the other binomial. So what FOIL stands for is the F stands for the first, the outside stands for the outside terms, the inside for the inside terms, and the last for the last terms. So it's basically just an order on which you multiply those monomials together. Now, it doesn't really have to be in that order, but it's just kind of a nice way to think about it. You can also make these lines. Okay, so 8x times the 2x, and then 8x times the negative 3, and then do the same thing to the 1. So basically, you're just distributing the 8x, and you're distributing the 1. So this one, we got 8x times 2x. That gives me 16x squared. Okay, the first one's the outside, so the very outside terms are the 8x and the negative 3. That's going to give me a negative 24x. The insides, 1 and 2x, that gives me 2x. And 1 times negative 3 gives me negative 3. And you can also combine like terms here. You notice how we have an x term here and an x term here. So what will a negative 24x plus a 2x give me? Well, that's just going to give me a negative 22x. So we got 16x squared minus 22x minus 3 for my final answer. So the next one here, again, FOIL through, make those lines. Those lines help a lot. So 7n times 3n, that gives me a 21n to the second. 7n times negative 1 will give me a minus 7n. 5 times 3n, that gives me 15n. And 5 times negative 1 gives me a negative 1. And you can combine these two together. So 15 minus 7 gives me 8. So I have 21n to the second plus 8n minus 5. Now those terms in the middle might not always combine together. But just remember, terms that are alike, that have the same variable and exponent, we can combine together. So just a few more examples. So draw your little lines, the FOIL. So 7n times 7n, that gives me 49n squared. The outsides, that gives me 42n. The insides, negative 3 and 7n, that gives me a negative 21n. And then negative 3 times 6 gives me a negative 18. So we have 49n squared, and then we can combine these two, so that gives me a 21n and then minus 18. And we have that one there. And the last one for this little chunk here. So distribute that 6x through. So 6x times an x will give me 6x squared. 6x times negative 1 gives me a negative 6x. The inside one's negative 1 and x. Well, that's just going to give me a negative x. And then negative 1 times a negative 1, remember two negatives gives you a positive, so positive 1. And once again, I can combine those. So we have 6x squared minus 7x. You can imagine that as like a 1, and then plus 1. So I should also mention the box method way of doing these problems. So I'll just do it for these two. You guys will get the idea. Again, just kind of make the two binomials in a 2 by 2 box. So we have 7n minus 3. So you can put that either on the top or left-hand side of your box, 7n and negative 3. And then we have a little 2 by 2 box. And then we have 7n plus 6. Okay, so 7n, that gives me 49n squared. 7n negative 3, that gives me negative 21n. 7n times 6, that gives me, 6 and 7 gives me 42n. And then 6 times negative 3 gives me negative 18. So we have the same terms here as we did here. And then if you look at the n terms, we can combine those together. So just list the terms out in standard form. So we have 49n squared. When I combine these two, I get, again, 21n. And then minus 18. Okay? So that's the idea behind the box method for foiling. So of course, the next one you would set it up with your box 6x and -1, and then x, and then -1, just like that. And I'm not going to go through that one. I think you guys will get the idea behind that. So a few little more lengthy problems. These look a little complicated, but they're really not too bad. But basically what you're going to do, and it's a lot like the foiling, take the two terms in the first set of parentheses, the binomial, and you're going to distribute it to everything in the other one. So that one's a trinomial since it has three terms. So you got to multiply that 5n through. You also need to multiply that -6 through. So let's go ahead and do that. So you might notice that you're going to have 2 times 3 gives me 6, so I should have 6 terms when I do this first multiplication step. So 5n times 7n squared. 5 times 7 gives me 35. And then I have n and n squared, so that gives me n to the third. 5 times -8n, that's going to give me a -40 n squared. 5n times 1 gives me 5n. Okay, so we're done with that 5n. Now we need to multiply that -6 through. So -6 times 7n squared, that gives me -42 n squared. And then -6 and -8n, that gives me a positive 48 n. And then -6 times 1 will give me -6. So you notice how I have 6 terms in total. And now let's combine like terms. So you notice how we have -40n squared, -42n squared. Those can combine. And I can also combine the 5n and the 48n. The n cubed and the straight up number cannot be combined with anything, so we'll just leave that in the front and the end. So my final answer should be 35 n to the third. Combine the n squareds, that's going to give me a -82 n squared. 5n plus 48n, that's going to give me 53n, and then -6 on the end. All right, so let's do one more. Again, take the 4n, distribute it to every piece. Likewise with that 8, I'm going to distribute that to every piece in the other set of parentheses. So 4n times 8n squared, that's going to give me 32 n to the third. 4n -8n, it's going to give me a -32 n squared. 4n and 7 gives me a 28 n. So we're done with the 4n. Now the 8 through, so that's going to give me a 64 n squared minus 64 n plus 56. All right, and now combining the n squares and the n's. All right, so we got 32 n to the third. -32 and 64, it's going to give me a positive 32 n squared. 28 minus 64 will give me a -36 n, and then plus 56. And that will be my final answer. So the last type that I'm going to look at is one like this. Now I'm only going to go through one of them because it's pretty much the same idea as the last type problem. It's just we need to distribute another thing through. So looking at this, we have 3 pieces on the left side. So I actually need to distribute that 7p squared. I also need to distribute the -p, and I also need to distribute the -7. So when you do the first multiplication step, you should have a total of, well, 3 times 3 would be 9 terms. So first off, let's just do this. So 7p squared and 6p squared, that's going to give me 42p to the fourth. Uh, 7p squared times 7p, that's going to give me 49p to the third. And then 7p squared minus 8, that's going to give me a -56p squared. Okay. So we're done with that 7p squared. Now we're just dealing with the -p. Again, we need to distribute that guy through. So negative p times 6p squared, that's going to give me a negative 6p to the third minus 7p squared plus 8p. So there's that negative p through, so double check my work here. Okay, looks good. And now we have to distribute the negative 7 through. So negative 7 times 6p squared, that's going to give me a negative 42p squared. Then I'm going to have a negative 49p, and then a positive 56. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9 terms, so we're good there. And then we just need to combine like terms. So I have a p to the third here, and another p to the third. I have a p squared, another p squared, and one more p squared. And then I have a couple p terms. I have 8p and negative 49p. So writing off in standard form, remember start with the higher power, so I have 42. P to the fourth, so we're done with that. Now the p to the thirds, so I have 49 and negative 6, so that's going to give me a 43p to the third, so we're done with those. The p squared, so 56, negative 56, negative 7, and negative 42. Punch that in my calculator quick. Okay, all those together give me a negative 105 p squared. So boom, boom, boom. The p's together, so 8p minus 49, that's going to give me a negative 41p, and then plus 56. And that is my answer.